Hello. In this presentation I demonstrate how to use Andrew Hayes' process macro to carry out moderated multiple regression involving a two-way interaction among independent variables. I will demonstrate models incorporating continuous and/or binary IVs as predictors of an outcome variable y. Note that in the models that follow, the x variable will be treated as the focal independent variable and the w variable is treated as the moderator variable, which reflects the manner in which process is set up to input these variables. Nevertheless, due to the underlying symmetry in moderation, the designation of x and w variables as focal IV or moderator is more of a conceptual or a theoretical issue rather than a statistical one. A copy of this PowerPoint can be downloaded from the link under the video description, so please consider downloading it as it goes into a lot more detail than I can provide in a timely fashion in this video. Also, there is a link to the data that I'm using in the presentation as well, so be sure to download that as well. So if you find the video and materials useful, please take time to like the video and share the link with others, and also please consider subscribing to my YouTube channel. So the example and the data that I use in this PowerPoint are based in part on those found in a book that's entitled Doing Statistical Mediation and Moderation. So it was written in 2013, but it's a really nice presentation on these topics, so be sure to check it out. So let's start off with example 1. In this example we are predicting hope from negative life events, with grit serving as a moderator of that relationship. So in other words, we have negative life events being treated as a predictor of hope, and grit is the moderator variable in this model. We are also assuming that all three variables are continuous. Now to use process, and right now I'm just going to go through a couple of slides and then I will open up SPSS and walk you through the steps that I'm going to be using. But to go through this in process, or to use process, we go to Analyze, Regression, and assuming you've downloaded and installed it to your computer, you'll go to Process. Right now it's version 3.3 by Andrew Hayes. The box on the right will open up and you'll move your dependent variable. In this case we've moved the hope variable to the y box. We moved our x variable, our focal predictor, to the x variable box, and then our moderator variable, which is grit, to the moderator variable w box right here. And we've also set the model number to 1. Next, if you click on options, you have a variety of options that are available to you. First off, you'll notice that I've clicked on mean center for construction of products. So oftentimes mean centering is utilized in the case of moderated regression. It's not a requirement, but it can facilitate interpretation. Also, if I want to generate simple slopes, or basically plot the simple slopes, then I can click on this button right here. You'll also see that I've clicked on -1 mean and +1 for conditioning values, and then I've also clicked on Johnson-Niemann output, and I go into more detail on these options in the PowerPoint, so be sure again to check that out. So here's our data set. There's hope, there's grit, negative life events, and then we've got several others that we'll be using later. So what we'll do is we'll go to Analyze, Regression, go down to Process right there, and you can see I've already been kind of working with this, so I'm just going to reset this so you can see it. The model number is set to 1, so make sure that's set. We'll move hope over to the y variable box, we'll move negative life events to the x variable box, and we'll move grit down to the moderator box right here. We'll click on options, and you can see right here I'm going to click on generate code for visualizing interactions, and we'll mean center for the construction of products. Over here under probe interactions, you can set it to one of these options right here. Right now the default is if p is less than 0.10, or you could set it to always. It doesn't really matter, but I'm going to just go ahead and stick with the default, and then I'll use conditioning values, really more of the conventional pick a point approach. And then there's Johnson-Niemann output right there. So we'll click on continue and then on OK. and takes a couple of seconds, but there's our output. So you can see in our output there's our outcome variable right there. We get the basic model summary results. There's our multiple correlation, R-square value, F-test. There's our degrees of freedom and p-value for that. You'll see under model right here you've got the constants are intercept, negative life events, grit, and this is the interaction term right here. Under coefficients, these are the regression coefficients, standard errors, t-values, p-values, and so forth. I know this is probably pretty small on your screen, so again, check out the PowerPoint. You should be able to see it a little bit better. So also down here you'll see we've got the test of the highest order unconditional interaction. So this is basically an R-squared change. It's basically analogous to a hierarchical regression where you would first test the effects of the independent variables alone and then test a model that incorporates the interaction term. So this would be the change in R-square as a result of incorporating the interaction term in a second step. And then down below you've got the conditional effects of the focal predictor at those different values of the moderator variable. So, and then scrolling down you can see we have the Johnson-Neiman output which is given right in this area right here, and then down below you can see that we have basically some syntax that we can use to essentially generate plots of our simple slopes. So just kind of going through some of the output right here, you can see our interaction term is statistically significant, which suggests that the predictive relationship between negative life events and hope is moderated by grit. And basically the R-square value that's given right here basically indicates that incorporating the interaction term that basically accounts for an additional roughly 1.4% additional variation in hope. You'll notice the p-value is exactly the same as what you see right here. The f-value is just basically the square of this t-value that is given right here. So there's not a whole lot new information that's given in this section, but that's what that is reflecting. So here we have the effects of negative life events and grit on hope, and basically you would interpret the coefficients as the predictive relationship between the individual predictor and hope when the other predictor is set to 0. So basically, according to Hayes, the language that researchers should be using when referring to the effects of X and W is not main effects or the effects of these variables controlling for the interaction. Rather, since the slopes represent the effect of X or W on Y, conditional on the other variable being 0, then it is really more appropriate to think of the conditional effect as akin to a simple effect or a simple slope. So given that, because we mean center the IVs, we can now interpret these coefficients as the relationship between each IV and the DV at the grand mean of the other IV. So in other words, the effect of negative life events is negative 1.276 for those individuals scoring at the grand mean on grit. The effect of grit is 5.7082 for those individuals scoring at the grand mean on negative life events. So since the interaction term in our model was statistically significant, we want to probe the interaction to better interpret the nature of the moderated relationship between negative life events and hope. So these tests are simple slopes which test the relationships between negative life events and hope at 3 levels of the moderator, more specifically at -1 standard deviation at the mean on the moderator and +1 standard deviation on the moderator. So looking at our results right here, you can see that at -1 standard deviation, which on the grit variable is -0.6145, the effect is -2.8772, and it is statistically significant. At the mean on grit right here, we also have a negative relationship. It's -1.276, and you can see that it's statistically significant at the conventional 0.05 level. But at this high level on grit, which is +1 standard deviation units, the effect is positive, and you can see right here that it is not statistically significant. So basically, -1 standard deviation and the mean on grit, you have negative relationships between negative life experiences and hope, and both of those are statistically significant, whereas at +1 standard deviation, the effect of negative life events looks like it's positive but is not statistically significant. So this is the Johnson-Niemann output right here, and so you can see that we have the conditional slopes that are shown in the effect column, and you can see that as we move from more negative levels of grit to more increasingly positive levels, the effect of negative life experiences moves from very negative to increasingly positive. And what you'll notice though is that these regions right here on grit are basically indicating significant relationships between negative life events and hope. Okay, so let's say we want to plot out the simple slopes. Well, what we would need to do is to double click on the output so that it opens up and we can copy this syntax right here. So it starts with data list free and ends with the period on this last line right here. So I've just copied it, and I'm going to open up a new syntax file, and I'm going to paste this in and then highlight everything and then click the green button. So when I do that, you'll notice that there's a little bit of a plot down here. It's a little difficult to read, but you can see there's at +1 standard deviations on grit. This is right here the mean on grit, at the mean on grit, and this would be at -1 standard deviation on grit in terms of the relationship between negative life events and hope. Now, if you want actual lines, we can do this a lot easier just by opening up this file. So the syntax actually generates a new data file. So now we have negative life events, grit, and hope right here, and basically just different combinations on these two variables right here, and then the predicted or conditional value on hope. So let's go ahead and plot this out. So we're going to go to Graphs, Legacy Dialogs, go down to Line right here. We're going to click on Multiple and then Define right here. We'll click on Other Statistic Mean, and we'll just move hope over to this line right here, and we'll move negative life events to category axis, and then grit, which is our moderator, which is define lines by. We'll click on OK, and there you go. So now we have a plot of the simple slopes for the relationship between negative life events at essentially -1 standard deviations below the mean, +1 standard deviation that's above the mean, and at the mean on grit. So as you can see right here, it's also possible to incorporate covariates within your model. So we still have our y variable, our hope variable right here. Negative life events is our focal independent variable. Grit is our moderator variable. And then I've got essentially a life satisfaction measure as a covariate. So let's run the analysis in SPSS. So we'll go up to Analyze, Regression, and again Process. And so this is our satisfaction with life scale. I'm just going to move it to the covariates box right there. I'm going to leave everything else as it was before, and so we'll click on Continue and then on OK. And so now when we're running the analysis, there it is. So you can see right now that we've got life satisfaction that has been added to the model, and you can see again that basically the interaction term was statistically significant. Adding in life satisfaction, that was also statistically significant in the model. So again, going back to our slideshow, we see that the interaction term was statistically significant, as was life satisfaction. And then also the conditional effect of grit at the grand mean of negative life events was statistically significant. Looking at the tests of simple slopes, we see that the effect of negative life events on hope is negative and statistically significant at -1 standard deviations on grit, but it was actually the relationship was positive and statistically significant at +1 standard deviations on grit. And so you can also see our profile plot with the simple slopes plotted out. Furthermore, you see, using the Johnson-Neiman output, the ranges on the grit variable where the relationship between negative life events and hope were statistically significant. Okay, for example 3, we're going to be running the same model as before, but incorporating the use of a binary moderator variable. Basically, we have grit where I performed a median split and essentially dummy coding that variable, 0 for low and 1 for yes. So please keep in mind this is for demonstrative purposes only, and it's not something I would generally recommend. We'll also leave life satisfaction in the model as a covariate, and I will manually center the negative life events variable and then include it in the model so that it is the only IV that is centered. So step 1 is just basically centering the negative life events variable, so that means obtaining the mean on the original variable and then using the compute function to create a newly centered variable. And then step 2 will basically involve running the analysis by incorporating the newly centered variable as an X variable right here and our median split version of grit right here, and then this is our life satisfaction variable right here. I probably ordinarily would have centered that variable as well, but we're not going to do it for this particular demonstration. And notice that we're also not clicking on mean center for the construction of products for this particular demonstration. So doing this in real time, what we'll do is we'll just go to Analyze, Descriptive Statistics, go to Descriptives, and I will move my negative life events variable over to the variables box right here, click on OK, and you can see right down here that I've got the mean for that particular variable. So it's just 1.1342. So next we'll go to Transform, Compute Variable, and then I will type in just give it a name, and then we'll use the numeric expression in order to create that centered variable. So we'll call this variable neg life evts dot cent for centered basically, and then we'll move our variable over to this box right here and then subtract the mean that was in our table from descriptive statistics. We'll click on OK. And so now we have a new variable, which is the negative life events centered variable. So next what I'll do is I'll go ahead and rerun the analysis, and I'm just going to take this variable out and we'll add in negative life events to the X variable box. I'm also going to take out the grit variable and put in the grit median split version into the moderator box. Under options, I'm going to deselect mean center for the construction of products. And there's no real reason to click on Johnson-Neiman in this particular case. So next we'll just click on Continue and then on OK to obtain our output. So there it is. So here we see the interaction term is statistically significant, which is consistent with the hypothesis that the binary grit variable would moderate the effect of negative life events on hope. We see that the effect of centered negative life events on hope was positive, and actually it was negative and significant. Sorry about that, that was a bit of a typo. The regression slope for negative life events represents the relationship between negative life events and hope in the low grit group. That's the group that's coded 0. So in short, among those lower in grit, there was a significant negative predictive relationship between negative life events and hope. If we want to compute the slope for individuals in the high grit group, which is coded 1, all we would do is take the slope right here for negative life events and add the slope for the interaction term right there, and that's what gets us the slope in the high grit group. We also see that grit was a positive and significant predictor of hope. This is interpreted as the difference in conditional means on hope between the low and high grit groups for persons scoring at the grand mean on negative life events and controlling for life satisfaction. And finally, we see life satisfaction was a positive and significant predictor in the model, controlling for the remaining IVs in the model. The result indicates that persons scoring higher on life satisfaction were more likely to experience hope. So we can also look at the conditional effects of the focal predictor at the two values on the moderator variable. So in the low grit group, the slope for negative life events on hope is negative and significant, whereas in the high grit group, the slope is positive and statistically significant. So you can see kind of a picture of those relationships in our plot down below. So basically you can see right here we've got grit, median, split. So this is essentially the low grit group, and this is the high grit group right here. Okay, so finally our last example, we're going to include a binary independent variable, negative life events. Also basically a median split was performed on it. So negative life events is coded 0 for low, 1 for high, and we have our binary moderator variable grit, which is coded 0 for low and 1 for high. And for the sake of simplicity, we're just going to remove life satisfaction from the model. So this is what it's going to look like when you're running the analysis. You can see right here we've got negative life events. That's our binary variable, and then our binary moderator variable right here. So as you can see right here, the interaction term is actually not statistically significant in the model. So let's quickly look at the effects of negative life events and grit. So the slope for negative life events, or the median split of that variable, is negative and non-significant. The slope, however, would be interpreted as the difference in marginal means on hope among those low in grit, and the t-test is basically the same as a simple effects test of the difference following a factorial ANOVA for this group. The difference in marginal means for those high in grit is essentially 0.6815. The slope for grit is positive and significant, and this slope is the difference in marginal means on hope for persons falling into group 0 on negative life events, that is, those who are low in negative life events. And this t-test is the same as a simple effects test following a factorial ANOVA in this group. And the difference in means between grit groups in the high negative life events group is essentially 6.6662. So I do want to point out that Hayes in his book does a really nice job of relating factorial ANOVA to moderated multiple regression when you have categorical independent variables. So that's definitely something to check out. Okay, so in the PowerPoint I do have some final notes regarding what to do if your interaction term is not statistically significant. Also, I do want to draw your attention to the importance of thinking about centering decisions when you are running moderated multiple regression, as it can have a substantial impact on interpretation. So you'll notice I strongly recommend getting a copy of Hayes' 2018 book on conditional process modeling, as it does go into terrific detail on the implications of centering decisions on interpretation of regression coefficients. Finally, I do want to mention that it is worth noting that under the options box you can click on heteroskedasticity consistent inference to obtain heteroskedasticity consistent standard errors if you suspect there's a violation of the constant variance assumption. So I wanted to point this out because I can see how it would be very easy to overlook this if you're not looking for it. Okay, so just so you know, on the last page of the PowerPoint there are references that I used to put this together that I drew on. So many of these are really nice resources, so you should definitely check them out. In particular, I'm just going to say again, you should probably check out Hayes' 2018 book and the book on doing statistical mediation and moderation. That's from 2013. Both of those are really nice books to learn more about this. So you can also obtain a a copy of the process macro at this link right here, so be sure to check that out. So that concludes this demonstration, this video overview of moderated multiple regression using the process macro. I appreciate you watching.